Hello everyone. So I'm going to share the link. So we had a problem with the other account. I'm going to create. Oops. What the fuck? Yeah. The new link has been posted on the previews. Salut Eve. I'm gonna share the other thing. New link. So you see me, Eve. Can you log inside the Hangout? And does anyone can connect? Présenter à tout le monde. No, I can't hear you, but how can we do that? Sad that you can't talk. You should be able to talk. Okay. That's strange, right? So how much visitors do we have? 7. I don't know who sees whatever. It's so strange. Cool. So unfortunately, yes, I think there is a chat. I hope so. I think we can chat like that. usual chat. Question and answers. That's bad. You cannot log in with me. I thought it was possible. Anyway, I think we can start. So I will share my screen. Hopefully that works. I tried. So, I don't know. We can start if you wish. I don't. We will. If people comes along, they will catch up where we are. Can you see my screen, by the way? I think you should be able to see my screen. So that's too bad. We cannot talk. Maybe you can ask questions on the event page, like here. Ask any question here. Good, thanks, Sylvain. So I prepared some slides. I will go there. I have the link somewhere. Slides are here. And you can connect here to my teammate session, which is this link. Sasha, you're right. So here's my teammate session. It's read-only so that people can't RMRF all my computer. So we will start. I'm a bit stressed. I'm sorry. I will try to do my best. So here we are. I will put it full screen or something. No need to put full screen. Oh yeah, delay. Yeah, okay, I see. So I will make my monologue as usual, and you will tell me if you have any question. So we are going to try to dive into Docker. We start for real 15 minutes late. It's not a problem. So what we are gonna try to explain is what is Docker. So Docker is a tool to help you containerize applications. So the underlying technologies that are used behind the scenes are like normal Linux capabilities or modern kernels that appear since maybe 10 years ago, that are used by Google and other virtualization or cloud engine or something. And it uses mainly process namespaces and C groups. So process namespace is the idea that the kernel isolates processes from one another. So one container does not see the processes that run on the same operating system. You cannot see the processes of another container. So that's isolation compared to virtualization with a virtual machine hypervisor. But the idea is approximately the same. Is you try to isolate the processes from one another. So process namespaces are, like I said, you in a container, the first process that is run has PID 1, even though the real process has a PID outside of the container, which is a different one. So containers only see things that are inside its container and only. And C groups are also a Linux capability. You can use it outside Docker. it's a way to limit the different possibilities that has a process. For example, it's built inside modern kernel, so you can introspect and manipulate processes using /proc/PID. So for example, I have somewhere here, I have my Firefox that runs. Firefox is 16826. If I go on /proc/16826, I can introspect what this process is doing. For example, I can see what C groups are applied on it. So I can see that systemd applies some scope on the thing. I can limit the amount of memory. I can limit the amount of cores of my CPU. I can say like 2 cores for this process and 4 cores for this one. I can limit the amount of network accessible, what devices are available. I can allow to mount or to access the /dev/sound or something and stuff like that. You can also introspect what command line was run, and you even have access to the environment of this process. So it's very interesting. So that's built-in Linux capability. It's nothing magical, just that Docker uses a nice API to create those processes automatically. So it will automatically apply some groups limits. For example, I use C groups locally to limit the amount of memory used by my Firefox or Chrome, and you can see that I use C groups, CG rules, and cgconfig.conf, and I say that everything run by Florian, so user Florian, for this binary will be limited by memory for the browser's group or config. And the browser config is this group here. And I say limit memory to 2 GB and make like if the soft limit is a limit visible by the process is 1 GB. So it will never ever use more than 2 GB on my machine. And if the browser or the process tries to allocate using malloc, it tries to allocate new memory, it will fail, simply fail. It will say no more memory on the machine, and it will not create a new tab if it's failed, if it can't. So that's how it works. So that's the C groups thing. And then namespace, we can directly go and see what the engines look like. So at the engine, there is different tools available in the Docker ecosystem. So the toolset mainly consists of the engine. So what you're using Docker run and the Docker command line. There is a machine we will see later, and there is Docker Compose, which are the 3 tools we will see today. I will see if there is any question. Okay. So the engine consists of 2 different parts, mainly. So the client part and the server part. So the server, it's using the same binary behind the scene, but it's really 2 logical different things. So the Docker daemon is where you see when I psfax grep Docker. You see there is docker-d here. This says Docker run as a daemon. Oh, I see some mates are connected to my teammate. That's great. So the Docker thing here, -d, so I run Docker as a daemon and listens to fd. That's Unix socket, which is inside var run something docker.sock. So that says Docker listens on the docker.sock, but it can also listen on TCP or and that maybe that's all. So I'm glad you like it, Ryan, and don't hesitate to ask questions, because unfortunately I wanted it to be interactive, but you cannot talk, so it's a bit sad. Yes, so Docker socket, so that's a typical Docker socket, and there is TCP socket. Behind the scenes, this daemon listens to HTTP requests. Though everything that is made with Docker is run through HTTP API, standard HTTP API, and you can look at what it looks like. It's in the Docker docs API. It's a very well made API, which is well versioned. It doesn't break. It's BC compatible and everything, which is quite great. And you can see you just send like post or get or put events, and that's it. And what this Docker daemon does is you say post slash container slash create. You give him a configuration. We will see that later. You give him a configuration to create a container. You say to him, okay, I want this container to be named PHP1. I want it to mount a volume from this location inside this location. And you want to limit the memory. And this is a config.json file that contains that declares how the container should look like, and also which image it comes from, and stuff like that. So that's it. And then the Docker daemon receives this request and will talk to the Linux kernel behind the scene, or the API, and creates a container, creates a kernel namespace, and create a C group, and apply the rules on it, and then run it. You can do exactly the same using low-level commands, using LXC. So I don't have LXC installed locally, but LXC is also the name for Linux containers. It's I think the first tool that really leverages the Linux capabilities to make containers. But using the LXC command, you can also create a container, run it, mount some volumes in it and stuff. So you don't need to have Docker to make containers. That's first thing to say. It's just that Docker has a nice UI on top of it. So then the second part of the Docker binary is the Docker client. And when you type Docker PS, for example, you see that it will make a HTTP call to the Docker daemon, which is stored locally. It's running locally, but you can run it somewhere on the network in a cloud environment. So any daemon that runs and accessible, you can talk to it, and the same command applies. So Docker PS, here I'm currently talking to my local Docker, but we will see later that we can talk to a daemon running inside AWS, Amazon AWS. So Docker PS behind the scenes make this HTTP call, get / processes, and you have all the things. So we can see what it looks like. I will remove all the containers. So here I'm making a brutal RF of all the containers, but it's not very important because I will be able to create them back later. We will try to Docker run something. So what we do is Docker run. That's a basic, I'm sorry, but we will start anyway. So Docker run, I say to be interactive, so I can type chart characters that will be sent, and T to attach a TTY, so to have a kind of a terminal. And I say to run this image. So image are named. There is an official image on the Docker Hub, which is named Ubuntu, or I can use Debian. It's smaller, I prefer. And then you can ask from this image to create a container and run bash in it. And you see instantly, almost instantly, it will create a container and from this image. So what is an image, you will ask? So an image is a set of layers that contains all the files needed to make something. So Debian, for example, consists of etc/something /bin/something and /var, and all these files are a Debian. So if you can package those files inside a binary and give it to someone, it will be able to run its Debian. You can also do that with chroot. So if I give you a folder which looks like the root folder of Debian install, you can chroot inside, and you will be inside the Debian. So that's also the same thing. But let's look more in depth on what looks like an image. So Docker images. I have a lot of images. My computer is quite slow. My hard drive is slow, so images are stored inside a special kind of file system, which is, by the way, a bit slow because it's using the copy on write paradigms. So copy on write means that it will make a diff of what happens inside inside the file system, and every time there is a diff, you can decide to commit it or not. But unless you don't commit it, it will just, like, you will have this diff, but next time you kill the container, it rolls back to the last committed layer of an image. So that's great because you can modify everything inside your container, and you kill it and run it the same container with the same configuration, and you will be back to the same state as the last committed file system layer. So let's look at what does look like the Debian image, what layers it consists in. Docker history, it's will display how we made all these layers. So Docker history Debian. So it's really simple. In fact, it's not a good example because they just added a big file, which is consisting of all the file system needed for a Debian. So you don't see a lot of things. But if we do that for PHP, for example, I don't have PHP.7. So we can see that, again, it's based on the Debian thing. So we can see that they added this big file, which is a base file system, base folders hierarchy to run operating system. It only consists of 100 megabytes, but it's not that big. It's a very minimalistic Debian. And then what they do is apt-get update, install whatever needed to run PHP, and they add some environment variable, and they add some stuff. They copy a file here, and they say that the default command when you run this image will be php-a. That's all. That's how you create an image. And this image can be built either using the Docker commit commands or using a Docker file, which does approximately the same. But you instead of manually committing, it will read the Docker file, and for each step, it will commit. So each step consists of a new layer, and this layer is usable as an image. So I could, for example, look at what my image looked like at the first step. I could Docker run -it, and I copy the thing, and I run bash, and I am in the state of the image for the first layer, and I could do that. So this is a working image. It's not named. The final image, which is the sum of all the layers, is named php:7, but that's all. So that's how it looks like for the image. We will look later how we create our own image using a Docker file, because that's the best way to do it. And so that's a really basic thing of Docker run. There is also Docker inspect. So we can see how it looks like to see what does. So let's make a Docker PS. So here I don't run any container, but if I ps-a, I will see all the previous containers that are killed. So, but still the configuration exists in my machine. So finally, what is a container? It's just the execution of an image for a specific configuration. And this configuration, as I said, is just a JSON file which is stored locally inside your file system, inside where is running the Docker daemon. So if you go on the var run Docker, I think, not sure if it's there, Docker / no, I don't remember really. What is it? Docker, but it's not really important. But somewhere here there is all the container configuration needed. Yeah. So yeah, JSON file that says I want my container to run this image with this configuration, blah blah blah, and it's stored locally on the file system using a JSON file. You can look at it in varlib docker somewhere, but I don't really know where it is. Or you can also look at what it looks like using docker inspect. For example, is this one. So that's the container ID, but it also has a nice little name, say auto-generated. So let's look at boring query. What it looks like is boring query. I will just pipe it inside GQ, so it's a bit nicer. And you will see that that's a configuration to say I want Docker to run this configuration using one specific image. So you have the state, you have what image ID it is using. So this is the ID of PHP-7 : 7. So you can say I want to attach std in, attach std out, and all this stuff, and what command to execute when you run it, and what entry point it is, and really the list of all the volumes you want to mount and stuff like that. So what is a container to end? It's really that. To ask Docker to take this image, so the file system, so all the folders that are inside the image, and execute it against this configuration. That's it. So Docker itself consists of many different things. You can search for an image. You can see the stats, Docker stats. You have to give him an ID, and it will give you the amount of memory used by a container in real time, like a bit like top. You can kill, you can create, you can do many things that I don't use usually. You can export the file system or the file system of a container outside and create a zip archive out of it. So you have you can log. So logs are what comes out std out. So that's stuff like that. But usually you use Docker run, Docker kill, and Docker create. An interesting thing, what is run? Run is just a composition of create and run. So you can create a container in advance for a future execution. So what you do is you give the configuration, so the JSON file for one container, it will create it, but not actually run it. So the process won't be run yet, and you can run it later. So the advantage of that is that if you want to deploy something, but without any downtime, you can create the container. So it can take some seconds, for example, to create a container. But once it's created, you can run it very quickly. So once a container is created, it's there, and you can run it or kill it and pause, unpause, and that's an interesting thing. But usually you don't use that. So that's for the Docker engine. So the daemon that talks to Linux and the client that sends HTTP requests to the daemon. That's really it. Then let's try to not lose focus. We have the Docker machine. That's another tool. It's docker-machine. It's also a Go binary, so it's written in Golang. And Docker machine allows you to provision like a bit Ansible or Puppet or Chef, except it's written in Go. And its only goal is to create a running machine somewhere with a running Docker daemon that is accessible to a specified port and configured to be secure with a TLS certificate. So this Docker machine generates a certificate on the fly and configures everything so that you have your running Docker daemon somewhere. And Docker machine is no official way to replace boot to Docker, which is almost exactly the same, except boot to Docker was only meant to be used with VMware or VirtualBox somewhere. Sorry. But Docker machine is a generalization of that, so you can talk to Amazon or DigitalOcean or your local VirtualBox. So that's just a generalization of boot to Docker. And this Docker machine, using that, you can create a new machine. And if I look at my current existing machine, oh, it's LS. I have some machines running all on Amazon. I have one for my project. I have another one for my customer. For each of my projects, I have one. So that's for Docker machine. It's not really magical, but it works. And for example, with Docker machine, so I made a small alias DM is Docker machine, so it's smaller. So DM environment, for example, will of Docker Liver. It will give me how to configure my Docker client so that it can talk to the remote Docker daemon. So it's basically the IP of the machine and what certificate to use to securely talk to this machine. So each machine has its own certificates, and that's it. So you can see here, you just configure Docker using environment variable. So if you put that in your bash and you type docker ps, it will talk to the remote Docker daemon, and ps will return the list of running containers from this machine there. But that's it. That's what does Docker machine. And finally, last but not least, Docker Compose. So Docker Compose is the most interesting part for me because it allows you to let's say declare how your application tiers look like. So usually in an application you just not have one process, so you won't be able to, if you have to type docker run every time you have a process, it will be a bit annoying. So what they did is create a tool that talks to the Docker daemon, but instead of using the Docker client, so the Docker CLI client, they created a Python client that talks to this Docker daemon the same way, and it reads the configuration from a YAML file. That's all. And Docker Compose is usually the entry point to your application. So let's look like what it takes to make Docker Compose, a running Docker Compose ready application. So I created an empty Git repository, and what I say now is I will vim and create a first file, Docker Compose.yaml. And I want PHP. So that's the logical name of my service. So each service consists of one container. I can say use this image, PHP 7, and links to another container. So a link is soon to be deprecated way to make two containers communicate with each other. So by modifying the etc host file of a container and put a name for a given IP, which is the IP of the container you want to talk to. So I want to talk to DB, for example. And now I create the DB thing, again, the small name of my service, and I want to run PostgreSQL. Postgres. And that's it. Using that and running Docker Compose, so DC up DCU. So again, DCU is alias DCU Docker Compose up -d, so in a detached state. So it will run the container and give back the hand to the prompt, the DCU. We'll see how it looks like. So that's the cool thing with Docker is if the image doesn't exist locally, it will try to pull it from the Docker registry, and the hub.docker.com is a public registry where you can push and pull all your images. You can also create private registries, so you don't have to share it with everyone if you have a like secret code or something. But the good thing is that most of the tools you want to use are already there, and it's official. They are officially maintained by the guys and validated by Docker, so you always have the latest version, and it's well thought, and you don't have to redo it again. So I'm really in favor of reusing existing Docker image and official one even more, because they are verified and everything, and you can also always modify it. So people who say I can't use PHP because it doesn't have this extension, it's wrong. You can totally add it later, and we will see how. So that's it. It downloaded my image, so you can see it consists of many layers, and it has been verified. That's good because it's an official image, and it created the two containers out of it. So let's try to make DCP again. It's an alias for Docker Compose PS. So it's like filtering all the Docker PS. It's like Docker PS, but filtering only the containers for this project. So you just see your projects, your containers for this project, the DCP, and we can see PHP didn't run very long. It's exited, but that's logical because what it runs is PHP-A, and PHP-A doesn't last long. So what you want to do instead is, for example, say that what I want to run, and this is just a hack to make it last longer, I want to run command php-s localhost 8000, for example. And if you go there right now, so you can rerun the thing, DCU, it will detect that PHP changed, so the configuration for the PHP container changed, so it will create it. And now if you go again DCP, you see that it's running php-s localhost 8000. So now what it is to know is that if I try to listen to localhost 8000, for example, let's say I want to try there, there is nothing running because we have to think about the container is like its own machine, so it binds to the port 8000 of this interface, and the localhost interface is by definition local. You cannot see the port or bind to this port or connect to this port from the outside of the machine, which is our case because my machine is not the container machine. So what you should do instead, you can ask to expose a port, and you can make some kind of NAT redirection saying that the port 8000 runs on the port 8000 here. I should be careful because YAML specification says that something that starts with 8 is an octal thing, so I should wrap it inside string. So now 8000 maps to the port 8000 of this container. So this thing here is the port of my machine, and this is the port of the container. So this thing should be mapped to this thing, 8000 here. So now I will run it again, DCU. Okay, it will create the PHP container saying there is a new port to map. And once it's done, usually it's a bit faster, but again, my computer hard drive is slow. And now, if I go there, oops, I have a localhost.com, that's not okay. Okay, I don't know what it does, but let's try use curl. Curl localhost 8000. Collection used by peer. Okay, maybe that's a fun thing with. But maybe that's logical. Maybe that's because PHP doesn't send me anything because there is nothing to send. I'm not sure. But what is sure is that PHP doesn't send me anything here. But we can see that compared to the previously, here you see that was without the port mapping, and here that's with the port mapping. And we can see that Docker says, listen everything from 8000 to the port 8000. Oh no, I see why it fails. That's because I asked PHP to bind to this interface, but I want it to listen on any interface, so 0.0.0.0. And DCU again. So up services, we create services. I think it makes more sense now. So if you have any question, again, don't hesitate. I'm not seeing a lot of what you have to say. So it's created. Let's try to curl again. And here we are. PHP talks to us, and we can talk to the container using this port mapping. So now let's try to go inside the container and look at what it looks like inside this container. So I will docker exec. The docker exec is a way to execute a new process inside an existing container which is running. It's important to know that it has to be running. So what is the name of my container for real? It's its name is. It's a prefixed with the name of the current folder, so dive. So dive php_1. I will docker exec -it, name of the thing, and the process to execute bash. And I'm inside, and now I can try to ps. And what you can see ps-a, no, psfax, yeah. You can see the running PID of this container is 1, and it's PHP. So maybe some sysadmins will cry because PID1 is the thing that executes everything, and if PID1 dies, everything dies, which is the case. If PHP dies, my container dies. So if you make a fatal error inside your code and the process exits, your container will be killed, and you won't be able to connect anymore. But usually, hopefully, Docker, since a few versions now, allows you to make restart policies, which says every time the process 1 dies, restart it. And you can say restart it for 5 times, or restart only if the exit status code is 1 or 0 or stuff like that. And you can do that using that. Restart always. So right now, if I have a fatal error inside this process, it will still rerun. So a new container with a new ID, but the exact same configuration. So that's what it looks like to make a Docker exec. And if you are inside this thing, you can do whatever you want. You can modify the file. You can do stuff. But again, if you kill this container and restart again, you will lose every file you added because you didn't commit this diff, the difference, and it won't create a new layer, so you won't be able to see it again later. So I can try. Oh, for example, look what I'm doing. You always dream to do that, right? rm rf / oh, that's sad. It's dangerous to operate recursively. Yes, sure. /bin. I remove the bin, so I cannot do ls anymore. Oh my god, right? But it's not a problem because I didn't commit the diff. So let's kill this container. So docker kill. Docker kill. What does it get? Dive _ php1. I kill it, and I DCU the process again. So I create it back, and docker exec again, and bin /bin is back again. So you won't be able to break anything even if you wanted to, because the copy on write file system doesn't allow you to do anything, and you cannot commit it from inside Docker. So there is no Docker command inside my my container. So that's the cool thing. You are more secured by default if you containerize your application, because even if you remove everything, you just have to recreate the thing, which is great. So that's a funny thing, to rm/bin and see it works again. So that's something you cannot do with a virtual machine, because if you remove the content of the virtual machine, it will break everything, even if you start this virtual machine. That's a new advantage of the thing. So where are we now? Inside my thing, Docker Compose. So I wanted to talk theoretically about the paradigms behind the scenes. So why to containerize everything? So there is a few advantages. So we saw already like the practical advantages of copy on write, and the fact you don't commit the changes, and thus it won't break all the things. You just have to restart. But there are more conceptual advantages to containerize a thing, is that you are forced to think about how your containers communicate with each other, and you leverage TCP over Unix sockets, for example. So TCP has the advantage that it can talk to processes over the wire, as contrary to Unix sockets, which are local only. And it helps distribution of, or horizontal scaling of your application or your services or your tiers. So you could say you could create 4 containers for PHP, which are exactly the same configuration. And since they all talk to TCP to the same machine, it will work. You don't have to put everything in the same machine. So it limits the surface attack of your application because you have less softwares inside each part of your application. That's a good thing. And again, more conceptually, you have to think, which is usually a good idea. So you have to think how they communicate, but also why the hell would I need inside a PHP service? Why would I need, I don't know, MongoDB, for example? It's totally not the same process, and one is a database and one is a language. Why the hell should they be together? And stuff like that. Or you can also think, why should I need JavaScript NPM, and why should I need gulp and stuff like that? So when you start containerize your applications, you are going to detect, oh my god, my container needs everything installed. I need no MongoDB, I need PHP, but I also need NPM and Bower and everything. And you start to think, okay, maybe my application is too monolithic. Maybe it's not a problem, but at least it will make you think, should I not have this service inside this application or not? And usually what you see, if you have like Symfony with ascetic and everything, you start to see that Symfony does everything, and maybe it shouldn't. I'm starting to think that it's better to make like separate front from the application and make the PHP service a REST service only, without any view except the JSON. But no JavaScript, no CSS. Everything is done by another container, which is talking via TCP and HTTP, with the Angular application from one side and the PHP from the other side. And containerize, make it Docker friendly, will help to understand those kind of things. Or it could also bother you because it's like fighting against you doing what you want. You can also see it like that. And most of the time, when you containerize something, you say, oh, Docker fights against me. But maybe that's because you're trying to do the bad thing. But that's something to discuss. So what's next? So yeah, I think the main point is to help this. And also, as soon as you think of your application as one process that talks to TCP, it helps to scale compared to more complex setups and monolith, where you cannot scale as easily. It depends, because if you think of it, you can totally make a scalable application if you thought of it to be scalable, and you configure it with 12 factors in mind. So it's not because you don't containerize that you cannot scale, but at least to make it container friendly will help to scale, with a bit force you to think your code, make it more configurable and scalable. So that's a good thing. So does it applies, or does it matches Unix philosophy and do it the Unix way? Somehow yes. The Unix philosophy or principles are a bit very abstract. So it's try to say, do one thing and do it well. That might be the thing. Also, it says every program should act as a filter. So talk to STD, take STD in, modify it, and give STD out back. But I think the most important thing is, like, you can think of your different tiers or as just a step. So you can totally apply the Unix philosophy to a more message-based philosophy or something. So if you use RabbitMQ, do you apply the Unix philosophy because each worker modifies the input, which is the incoming message, and produces a new message? Does it apply to the every program is a filter? Maybe, I don't know. But it's not possible with Docker, for example, to use pipes. I mean, it has STD in, STD out, and everything, but you cannot say natively, at least, you cannot say, okay, this container get STD in from this container and passes to the STD in of another container. That's not doable because pipes is not TCP. But using tools like Netcat and Socat and stuff like that, you could maybe play with something. There are people who did kind of a Unix pipe-friendly version of, or at least a wrapper or on Docker to make Unix pipe work with containers, but it's not native. But there are many other things in Unix way that I didn't say, I didn't talk about. But we can say that Docker is very Unix friendly in some way, because you have to think at the exact same problem as when you do non-Docker Unix things. So yes, I think it's kind of the Unix way. So demo. I don't know how I managed to really, my slides are a bit mixed up, so that's demo time. We wanted from 0 to cloud. Oh my God, we only have 2 minutes left. So we didn't make really a live coding session for real. But what I can show you is how we can now deploy our PHP server inside the cloud very easily. So you see that my setup here, which is consisting of only 2 services, I could totally deploy it on another machine. And it would be very easy. So let's try to do that. I will try to create a Docker machine. So I will source my credentials, and you won't be able to copy the private keys, hopefully. And now I will try to make a Docker machine. Docker machine, create. Yeah, doing that. So I will call it dive. And what it does, it will ask Amazon to create a new instance. It will provision it with a Docker. It will be a Ubuntu installation, by the way, I think. It will create the TLS and configure Docker daemon correctly with these certificates and everything. And once this is done, we will just ask Docker machine to configure our environment variable to ask our Docker client to talk to the remote Docker daemon. And we will use the exact same command, so dcu, and it will deploy the exact same version, like exact same version, on the cloud. Unfortunately, again, it takes a bit time, and I didn't notice that we took an hour already, and that's the end of the talk, right? So what do you think, guys? Are you still there, by the way? I hope so. Do you hear me? If yes, move your hands. So I wanted to go a little bit more in depth, but I'm sorry, I just touched the very beginning of Docker. I wanted it to be a bit more complex. I wanted to declare services, so that we did, but it was really simple. We just made PHP and Postgres talk together. And we didn't even see if PHP could talk to Postgres, but I assure you it can. But well, PHP doesn't have any extension by default in this image, so you have to make a custom build, a custom image from this base image, and add this extension by saying PCL install something, and install PDO if you wish, install everything which is needed for PHP to work. So you create this custom image and use this image instead of the other one, and starting with that, your PHP can talk to Postgres using the PDO API and stuff. So there is a big latency. I'm sorry. So how they talk using TCP, and we wanted to implement more stuff, as I said, PHP FPM, because here we use a built-in server, which is not very scalable. It doesn't run very with a high performance. But adding PHP FPM is very easy. Out of the box, you can just say configure PHP FPM and ask Nginx to make a fast CGI pass to this container, listening to the correct port. So that's not Docker specific at all. But it's just that you can very separate Nginx and PHP FPM in two separate containers and scale Nginx and not FPM, or scale FPM but not Nginx. That's really great. You could add Varnish on top of it. Again, that's not Docker specific, but it's very easy to do with Docker Compose. Postgres, we saw it already. So we could IMQP. I wanted to make but really we don't have time to make that. But if we have a RabbitMQ, that is a central point, that is really our message broker, and we have different workers that talks each other. It's very nicely doable, and it's nice to do that with Docker. I successfully did that with Docker without any problem, and even more, it was cleaner than my usual approach. If you have a global RabbitMQ, and that's a point I wanted to discuss, is that with Docker Compose you can version the exact same, the correct configuration for your environment. Ryan, you have a very interesting question. So that's indeed a crucial point. How do you access the source files of your application? So there are two different ways. One is more portable than the other, and one is volumes. So you can ask Docker to mount a volume, but you have to think that the volume, or you give him a path to a directory, and this path is the path where the Docker daemon is running. So for example, if I have my remote instance on Amazon, which is bare metal, there is no file there, and I ask it to mount the volume, which is home/Florian/whatever, where my source code is. The path /home/Florian won't exist on the remote Docker daemon, where Docker daemon is running. So that's a problem with volumes, is that it's not portable. So the best solution would be not to mount the volume or directory inside the container, but it would be to create the image with the source files directly existing inside. So you commit the source code inside your image. And this, since this image is a big binary you can copy on different machine, each time you copy the image or you run this image on another host, it already contains the source code and you can execute it. And that's the preferred way for production. The only problem is that building an image can take time. So if you have to run composer install every time you modify the source code or something, building the image back will take time. And in a developer environment, it's not friendly at all. You want it to be instantaneous. So you modify the thing, and you want to, when you refresh the page 1 second later, to be the new code. That's possible with, if you're local, if you develop locally, you can use volumes. But if you don't, you have to copy the things. And we didn't see how, but it looks like, I will show you a real case. Dockerliver. I have a real example with Dockerliver. For example, I have a PHP service, and this is a Docker file, how to create my PHP service that listens to a GitHub hook. And that's how I do that. And you can see, so I use PHP 5.6. I install some things. So everything I do inside this Docker file will be accessible inside the image. And once you copy the image inside another host, everything will be already installed. So everything I did there will be available in the image. I asked to install those extensions, NBstring, Memcrypt, and stuff like that. I could try to ask to install PDO PostgreSQL. I activate the extension. And then you can see that I add dot, which is the current directory, inside the /code folder of my image. So what I do is I ask Docker, when it builds the image, to copy all the files which is inside my dot folder inside the thing. So everything which is inside the hook folder, so everything which is inside the folder where my Docker file is, will be copied. So actually it will be push7.json and web. So this add./code will copy all those files inside the /code folder of my image and will be accessible. That's the best way to do it. So if you're if copying and building the image is fast, you can totally add a guard or a listener that watches any change inside this folder, and every time he sees a change, make a Docker build. It will build the image, and it's quasi instantaneous. It's very fast, and you don't see any difference. Also, you have to Docker up, so Docker compose up again. So you build the image, so it's ready, containing the new code, but then you have also to build it back again to recreate a new container with a new image. So it takes a little bit of time, but frankly, if you don't have a huge thing to copy, it's almost a second. So it's okay. And the time you hit refresh, the new image is already up, and you don't have any problem. So that's how I do when I have a small amount of code to copy. If my Docker file doesn't take minutes to build, and if I can't, then I use a volume. And we can see how does it look like to use a volume. So maybe here I have a volume. Yeah, maybe I have a volumes. Well, my volumes here are a bit strange. Oh yeah, here I have an example of a volume. I will vim. It's maybe better. So yeah, here I asked Docker to mount the API folder inside the /code folder of my container. Again, this works only because I talk to my local Docker daemon. So volumes won't work if you talk to a remote daemon. But it's something they are trying to resolve using volume drivers. So one of the driver would be SSHFS. So you are able to mount a volume using SSHFS. So it's maybe slow, but at least it works. Anyway, this folder is now directly accessible inside this container, and everything you do inside this folder is directly and instantaneously visible inside the /code folder. So that's how you can develop locally without having to build every second your new image. I hope it answers your question, Ryan. And it's very tricky thing. During at first, I always used volumes, but it's somewhat problematic. So I prefer to now copy the files inside the Docker image if I can. And to answer your last question, are host machine files modify and vice versa? If you have a volume, if you declare a volume and if you mount a volume, yes, it's bidirectional. So if the container modifies something, it's modified inside your mountain volume locally and vice versa. So it's a way to persist your information. For example, your database data folder. You can mount the data folder of your MySQL, for example, so that it's kept in a separate folder. And this folder won't be copy and write anything. So if you kill the container or whatever, it won't change anything to your folder. So yes, it's a way to persist information through the life cycle of different containers. It also helps to share files between two containers if you need to. But again, it's usually not a good idea because it's becoming less portable. Because if one container runs on one host and one container runs on another host, it should be theoretically possible. They shouldn't see any difference. But if you use volumes, it's less portable. So that's the whole point. And that's the whole point of Docker, to be portable. So yeah, that's it, guys. I think we saw it all. Instead of RabbitMQ, we could use ZeroMQ. It's interesting. And that's all, folks. So with the latency, I hope you are still there, because apparently there is 2-minute latency. But anyway, we are 15 minutes late. So I will ask a question directly. Still there. So even if there is some latency, I will say you goodbye, folks, and thanks for listening. Hope it was not too boring. Hope you learned some stuff. And if you have any question, we can discuss that later without any problem. Cheers.